Chapter 4, Section 3, we're talking about discounts and markups. So first, you gotta know the difference between the two. It's like we're totally shopping today. Discounts. Discounts is the item less or more when it's discounted. Less, so we're gonna subtract, right? So whenever I say discount, I want you to say subtract. Ready? Discount.
Subtract.
Discount.
Subtract.
Perfect. All right, markup. Guys, have you heard that before, markup? That's like you own your own store and you mark stuff up. What do you think? Would we subtract or add it? All right, so whenever I say markup, I want to hear add. Ready? Markup.
Add.
Markup.
Add.
Discount.
Subtract.
Markup.
Add.
Discount.
Subtract.
Discount.
Subtract.
Guys, you got it. That's two of the main big ideas from today. You just got to remember the difference. We're adding, we're subtracting. The third main idea is very first in our workbooks. This is new. This is a new concept. I think of them as the backwards problems. We've done problems like this, but we haven't ever gone backwards from it. So let me put this into context. It's like we got a brand new shirt. We're wearing it. We're proud of our new shirt. And then your buddy comes up and you're like, nice shirt. And you're like, no kidding. I always wear nice shirts. You're like, thank you very much. And they're like, how much did you pay for it? You're like, well, I paid right here, $22.40. And they're like, cool. And then you're like, even better, it was on sale. It was discounted 30% off. So you're admiring your shirt. And then your buddy is like, well, how much was it before the sale? And then you're like, So I'm going to show you how to figure out what it is before the sale in case anybody ever asks you. So right here, a good strategy is to, in your notes, circle this. We're going to definitely use that 2240. Put a check mark by the 30%. We're going to kind of use that one. And then along the bottom, this is a really good visual. So this is our discounted price, right? So underneath this, just write discounted price. So this is our estimate. This is about how much the original was. It's not a ton more, but it's definitely more because we got a sale. Does anyone want to estimate this? Just number it. It probably was about this much before the discount. Alex, you want to guess? Sure. All right, let's put maybe $28. $28.50. Okay. $28.50 question mark. Okay, now let's figure out how much it really is. Question done. Feel free to do your own estimation in your book. I'm totally okay with that. And let's see how close you get. Okay, so what we've been learning is this percent proportion. Something over something equals something over 100. So let's do that still. So something over something equals something over, there's always a 100 right here, right? So now I've got 3 spots to fill. Here's the tricky backwards problem though. Tricky backwards problem. We already know how much you paid for the shirt, right? So you didn't have to get to the register and struggle to figure it out. We already know. You paid how much? Okay, we paid $22.40. Okay, stay with me. Think about this. So percentages is always out of 100%, right? We know we're paying $22.40. I would say that's 70% of the original price. Where did I get 70% from? You ready for a hint? I got it from here. But why 70? Well, you already know how much we're paying, so I'd say you're paying 70% of the original price. Where did the 70 come from? Heather, where did it come from?
Because if you subtract 100 from 30, it's 70.
Perfect. Take that 100%, subtract it. So we paid 70% of the original price. So let's actually change this. This is a backwards problem. We haven't had to do this before. And let's put that 70 right here. Okay. So now we've got difference over original equals percent over 100. So we've either got to put the 2240 for the difference or the original. Can you think about this? Was the 2240 the original price?
No.
It wasn't, right? We don't know the original price. That's what we're trying to do. So let's put the 2240 here. Huh? Make sense? So 70, that's got to take some work. And now, grab your calculators, type it in. Again, you guys are pros at this, but make sure you stay with me. Heads up, I'm going to call on anybody I want. So get ready. Okay, so we're typing in 2240 times 100 divided by 70. And I want Jake. Jake, tell us what you got.
34.8.
Oh, I got something smaller than that. Type it in again. 2240, $22.40 times 100 divided by 70. He's close though, huh guys? Like way close. Right. Let me see. Oh wait, that's farther off. Let me see what you're typing in. Let's go back. Look what you typed in. You gotta type it in. And then divide it by 12. Hey, Jake got 32. Is that what you guys got?
Yeah.
32. Okay, stop. Do we need to do anything else for this problem? No, that's the fantastic part of backwards problems. You don't have to do adding, any subtracting. You've already done that because the price was already there. $32. Did we get close? Was our estimate pretty close? Pretty close. $32. Okay, so 3 new things. When I say discount, you say? When I say markup, you say? And then we've got our backwards problems. Everything else we've done before. Okay, let's look at another problem. Oh, jewelry stores make so much money off of us suckers who like jewelry. Okay, so here's us. We're going to pretend we own our own small jewelry store. And we're going to make lots of money. You ready to make lots of money? Yeah. So draw an arrow to this. We're going to charge everybody 125%. Is that a huge markup? It's a huge markup. Okay, so we find this ring, this awesome emerald diamond ring, and we buy it for how much? $250. But we've got to sell it for more, right? If we don't sell it for more, we're going to go out of business because we're not making money. Now, look at this estimate. Here's how much. This is the original, right? So this is the original. This is what we bought it for. How much are we going to sell it for? I want an estimation. Look at this graph. Bam, right here. We can bam right here. And then a little bit more. What do you want to estimate it at? Michaela, what are you thinking? I'm going to take it. She said 525. I feel pretty good about that. Okay, write down your own guesses in your book. See how close we get. 525. We'll double it plus a little bit more. Okay, let's do the same thing we've been doing. Something over something equals something over 100. You ready? All right, so something over something equals something over 100. Okay, there's a dead giveaway in this problem. Guys, right up here, where does the 125% go? On top of what? On top of 100, because it's the percent, right? So that's done. Okay, now you've got a 50-50 chance. Would it be better if you could reason your way through? Where does the 250 go? Emily, where do you think it goes?
In the original price.
In the original price. Good job. Where is the original? Top or bottom? Bottom. So let's put the 250 in the original. Good job, Em. Okay, grab your calculators, type it in. Jake, you ready? Be very careful what you're typing and dividing. So we've got 250 times 125 divided by 100. I got 312 and 50 cents. How many got the same thing? So are we going to sell this ring for $312.50? That's definitely a markup, but didn't we want to mark it up big time? I would say that's not a big time markup. We got to do something. One more step on these. Jalen, what's our next step? Yes, add your original. We've got to add this to our original price. Holy money makers. Yes. Joey, what'd you get?
I got 562 and 50 cents, which is actually earlier on I did it a different way, and I got that exact thing.
You did. Totally works. Good job. How many of you got that? Good work. We're gonna make money in this jewelry store. Dagan, do you have a comment, question?
When I estimated, I got the exact answer.
You did. Jalen said he estimated perfectly. Good job, Jalen. Good work. Okay, let's the next part. I actually typed up some notes for you because in your workbooks it's like you're done, you understand, start your assignment. And I'm not confident. I want to do more examples before you do your assignment, so let me pass this paper out. Okay, so on your notes, Alec, you ready? On your notes, so key ideas, there's even a picture of a key. So we've got discounts and markups. Discounts, what do I want to hear? Perfect. Markups, what do I want to hear? Okay, perfect. So on your notes, there's a spot that says a discount, so what I have in green. A discount is what from the original price? Let's put subtracted. You always subtract it from the original price. Okay, and then the next green box in your notes says a markup is always added to the original price. I think that's logical to you guys. Okay, and then in the middle of your notes, there's a big blank spot. It's like right by that middle hole punch, a little bit above it. It says, what's the proportion we're going to use? this one, which we've been using. We're getting better and better at it. So copy this down in that blank space, kind of the middle of your page, right by the middle hole punch. We're going to use difference over original equals percent over 100. Let's keep using what you guys are getting really good at. Okay, now we're going to go shopping. I think what we're going to buy first is a shirt. Another shirt? Is that true? Shorts, you're right. We're going to buy shorts first. Okay, so the first exam, I'm going to make some more room for myself on the board. Okay, so right here, is it a discount or a markup? Okay, discount. What do I want to hear when I hear discount? Okay, so let's draw an arrow to this, and let's write subtract. We got to remember to subtract. And then let's put a big circle around our problem. Okay, pause. Is this a backwards problem? Do we know how much we're paying? No, we don't. We don't know how much we're paying, so it's not a backwards problem. This is just a regular old problem. So let's set it up. Something over something equals something over 100. All right, nice and loud. Where does the 25 go? Over the 100, perfect, because it's the percent. All right, I want a hand in the air for the 35. There's a few ways you can figure this out. Where's it going to go? Alec, where do you think? Original, right here. 35. You know what else I noticed? Is look at the keyword in front of $35. Hey, doesn't up go in that spot too? So there's like two ways we can think about this. All right, last spot is our variable. Okay, type it in. Get ready. I'm going to call on anybody I want. Make sure you have the percent proportion written on your notes. Okay, Jake, I'm going to call on you again. What'd you get? 8.75. I totally agree with you. All right, so these shorts, they were $35. So are we going to say we're going to pay $8.75 for them? No, that's like a wicked good deal. So we've got to do one more thing before you're done. Matt, do you remember?
Subtract 35 subtracted by 8.
Perfect. Take your $35 and then subtract that discount. Subtract that $8.75. Lauren, what'd you get?
8.40.
Oh, it couldn't be 8.40. That doesn't make sense. Take your 35, subtract it from 8.75. Feel free, we don't mind waiting. It's gotta be 30, no, it's probably in the 20s, huh? $26.25, she said. Is that what you guys got? Is that logical for discounted shorts? Yeah, we're good. How many of you, I got that one. Make sense to you? Don't forget to subtract because it's a discount. Okay, next we're buying, ooh, shoes. I am a sucker for shoes. Especially this, because I don't know how many of you shop at TJ Maxx and how they have the original price on there and then the TJ Maxx price. Does anybody knows that? It's the worst for me. Because I'm like, holy cow, these boots used to be like $150 and now they're only $60. I have to buy them. I can't pass up such a good, I'm one of those shopping suckers. So here we go, look at this. These shoes, do we know how much we're paying? Uh-oh, we know how much we're paying. How much are we paying for these shoes? So is this a backwards problem? It is, because we know how much we're paying. So we've got something over something equals something over 100. Be careful, we've only done one backwards problem so far. Does anybody remember one step from the backwards problem? Matt, do you remember?
Put 33 over x.
Yes! Matt, good job. He said put the 33 right here and put the x right here. 33 is not the original price, right? Because 33 is our sale price. So original, we don't know what it was. That's the whole point. We're trying to figure it out. Okay, this part's a little bit tricky. Do you remember what to do here, Joanne?
It's 40% off, so you put the 40 over 100.
So close. I agree with you. It's 40% off, so we need to look at that. So I'm going to write it down, Joanne. 40% off. Joanne, on the backwards problems, you got to think to yourself, we're not paying the 40%. That $33 is actually 60% of the price. And this is how I got it, Joanne. Percentages are always out of 100%, right? So take that 100, subtract your discounted price. Okay, shout out, what is it? 60. So Jovian, since it's a backwards problem, you gotta think to yourself, well, technically, we're paying 60% of that price. Two tricks on the backwards problems. Does that make sense, though, where we got 60 from? How many of you, I get where the 60 came from. Does that make sense? Okay, now you can type it in. After you type it in, do we have to do any adding or subtracting? No, it's glorious like that. Alex, what'd you get? 55. And then I'm hoping that you're stopping and you're thinking about it. $55 shoes that are on sale for 40% off. Would it make sense that they're about $33? Looks good. How many of you, even though it's backwards problem, I think I get those ones. You doing okay with those ones? Okay, let's keep going. What are we buying next? A bike? Oh, I love bikes. Okay, same thing. Let me move some stuff. All right, will you underline this word? Markup, guys. Markup stands for? We gotta add, right? So this one, now we've switched businesses. Maybe our jewelry store is so successful, we're like, might as well open a bike store too. So now we're gonna buy bikes. We bought a bike for how much? Okay, but we're the store, so we want to sell it. Are we gonna want to sell it for more or for less? We've got to sell it for more, otherwise we'll go out of business, right? So here we go. Circle this. This can be our setup. 20% of $70. So same thing, something over something equals something over 100. So redundant, right? Because where does the 20 go? On the percent. Okay, be very careful. I want a hand in there. Where does the 70 go then? Donnie, where do you think? Original, totally. Original right here. And you've also got your hint of. Go for it. Type it in. Solid. Make sure. So 70 times 20 divided by 100. Oh, I got these guys. You can shout it out. I agree. I got the same thing. So 14. So awesome. We bought a bike for $70. We're going to turn around and sell it for $14, right? No, hopefully you're like, wait. No, don't go out of business. We need one more step. What's the last step? Ethan, can you tell us the last step? Yes, perfect. Add it to our original, what we bought it for, $70. So we're going to sell this bad boy for how much? $84. Not too bad. Better be a good bike, huh? All right. Okay, now let's go to page 100 in your books. What page are we on? Page 100. This one, I kind of want to do the table together. Now remember, your assignment is page 100, but it's which problems?
5 to 9.
Yes, 5 through 9. So 1 through 4, let's do them together. And 1 through 4 is a great setup to help you with 5 through 9. All right, right here. Original price is $20. Percent of discount, guys, what? Shout it out, discount, what do I want to hear? Minus 20%. Let's figure out this how it works. Okay, get ready to write teeny tiny because we're going to squeeze everything in that table, in this little box. Okay, yes, we can do it. So our setup, something over something equals something over 100. All right, 20%, huge hint. Where does the 20% go? Perfect. Above the 100. Okay, now we have another 20 put somewhere though. Hint, look what row it's in. Well, column. It's in the original price column, right? So we've got to put it in the original spot. Okay, so make sure you have your setup. Again, this is a huge hint for the rest of your assignment. So squeeze in the setup. Oh, I guess you have room in your column. You can keep writing. Now, what did you get for this?
Isn't it 100 minus 20?
Oh, on this one, we already know the original price. So we're trying to figure out the discounted version of it. We'll get to that type though. Okay, show me with your fingers. What did you get? I agree with all those fingers. 4. So x equals 4. So we're going to sell this for $4.
Yeah.
One more step. Lauren, what are we going to do?
You're gonna add 4. Oh, subtract 4 minus 20.
Perfect. Let's do 20 minus 4 for our final answer of how many dollars? Done. Yeah, I was able to squeeze it in there. How about you guys though? Be able to get it all in? Okay.
Barely.
All right, number 2. Number 2, do you think it's the same, pretty same to number 1? Pretty close. Just different numbers in there? Okay, let's do the same setup. You ready? So on this one, we've got something over something equals something over 100. So this 35 is the percent, so it's got to go over 100. 95 in the column, original price, so it's got to go in the original spot. X for our leftover, same time. So 95 times by 35 divided by 100. 25 cents. Will you clap once if you got the same thing? Ooh, a lot of claps. Okay, but be very careful. Are we done?
No.
One more step. Can I have someone describe to me that last step? Alec, what do we do?
You add 33.25 to the original price.
Pause.
I mean, minus.
There you go. Minus it. So 95 minus 33.25. In dollars. I bet it's in the 60s. Does anybody have it? Josh, what'd you get? 61.75. Give Josh a thumbs up if you agree with him. Totally agree with you. Okay, number one, number two. How many of you? I got those type of questions. You okay? Just be careful with the markup and the discount. Markup, you would add it. Discount, you would subtract it. Oh no. Here comes number three and number four. Number three, do we already know how much we're paying?
Yeah.
Number four, do we already know how much we're paying? So this is a backwards problem. Backwards problem. So here we go. We've got something over something equals something over 100. In the backwards problem, is the 55.50 the original price?
No.
No, that's how much we paid after the discount. So that 55.50 has to go on the top right here. And then this is the trick. Okay, Joe, when you're ready, do you remember what goes here on this type of problem? The percent. Do you remember how to figure out the percent on this one? Starts as this. Okay, can I help you a little bit? Percentages are always out of 100. So you've got to do something with the 100 and the 75. Do you remember? Yes. Yes, Jovian, good job. So this one, we want to know what we're paying. That's not bad. We're only paying 25% of this. Okay, there's your setup. Once you've typed in your calculator, do you have to do any marking up or discounting? No, it's already been done for us. So help me out. I want a hand in the air when you have it. Courtney, what'd you get? 222. That is an awesome, awesome discount. How many of you agree with Courtney on that one? Good job, good job. Okay, let's do one more backwards problem. Okay, so it was 78, but, excuse me, we paid 78, but that was a 40% discount, so the 78 is not the original. Let's put it up top. Okay, does that 40 go over the 100 this time? No. Shout out, what goes above the 100? 60. 60. All right, type it in. 78 times 100 divided by 60. Cooper, what'd you get? 13. Do you guys agree? No. Couldn't be 13, buddy. Type it in again. 78 times 100 divided by 60. Would have to be bigger because it got discounted. What is it? 130. Is that what you guys got?
Yes.
Sweet. Thank you, Cooper. I bet you just forgot a 0 in there. How many of you? I got that. Same thing. Okay, 5 through 9 is the rest of your problems, but I kind of want you to buddy up. So we don't have time.